Good morning students, plus 2 physics. So now we are going to discuss about dielectrics and insulators. So what is by dielectric? So dielectric is a non-conducting material. So it doesn't conduct electricity. So it's a non-conducting material. So it doesn't have free electrons. So no free electrons. So dielectric is a non-conducting material. It doesn't have free electrons. The free electrons are bound within the atoms. What's my bound? So inside the atom, so it is highly protected without coming out from the atom. So it's a non-conducting material. It doesn't have free electrons. The free electrons are bound within the atoms of a dielectric. If external electric field is applied, the free electron just realign in the direction of electric field. So the dielectric is made either polar molecule or non-polar molecule. So how polar dielectric and non-polar dielectric? First we are going to discuss about non-polar dielectric. So non-polar dielectric means the centers of positive and negative are coincides. So there is an atom, that will be a positive and negative charges are there. The centers of positive charge and negative charge coincides. If you apply electric field, the negative charges address, positive charge move away. So it creates a dipole. So it's initially the non-polar molecules have no dipole moments, no dipole. If apply electric field, it creates a induced dipole moment. So non-polar molecules, the centers of positive charge and negative charge coincide each other. So there is no dipole. If you apply electric field, so positive charge just move away from the negative. So there is a equal and opposite charge separated by a small distance is electric dipole. Here by applying electric field, the charge is just separated from each other. So it creates a dipole. So by applying electric field, then only it produces a dipole. So it is induced dipole moment is produced. That is called polarization. In case of non-polar. So non-polar example, hydrogen, oxygen and carbon dioxide are examples for non-polar dielectric. In case of polar dielectric, so polar means, so what is a polar solvent? So already I have studied in chemistry. So polar molecule, polar means positive charge and negative charge actually separated from each other. So it creates a dipole. It have a permanent dipole already present. So there is a presence of permanent dipole without applying external electric field. So that is come under polar molecule. If you apply an electric field, but it aligns in random direction. So just see, it's a dielectrics law. So dipoles are already present. So equal and opposites are separated by a small distance. But before applying electric field, the dipoles are randomly oriented. If you apply electric field, so in case of we place two parallel plates, between the two plates we place the dielectrics law. So inside the dielectrics law, so dipoles are present. By applying electric field, that randomly oriented dipoles align in the direction of electric field. So it's polarizing. So it is also the net dipole moment is induced dipole moment. So a net dipole moment is induced. So what are the things we have discussed now? What is the main dielectric? So dielectric is a non-conducting material, doesn't have free electrons. The free electrons are bound within the atoms. So the dielectric may be a polar or non-polar. First, non-polar, the positive charge and negative charge coincide each other. Then by applying electric field, there is a separation between the two charges, it creates a dipole. So by applying electric field, induced dipoles produce. Example for non-polar is hydrogen, oxygen and carbon dioxide. If it is a polar molecule, already there is a electric dipole is present. So equal and opposites are separated by a small distance. So permanent dipole is present. In addition, we apply electric field. It aligns in the direction of electric field. So for example, for polar example is water, H2O, N2O, ammonia, then HCl. So from this HCl we can explain easily. H plus Cl minus separated by a small distance constitute the electric dipole. So it's a polar. By applying electric field, so the dipoles align with the electric field. The next, so again I am saying one thing, polarized. So what's the meaning for polarized means? By applying electric field, so the charges are coincide. So positive charge and negative charge coincide. By applying electric field, positive charge separated out from the negative charge. So it creates a dipole. That is polarization. So polarization is by applying electric field. So by applying electric field, by applying electric field, induced dipoles produced. So induced dipoles produced in the dielectric. So that is polarization. So polarization is defined as a dipole moment per unit volume. So total dipole moment. Total dipole moment per unit volume. So polarization is defined as total dipole moment per unit volume of a dielectric. So that polarization is directly proportional to applied electric field. So the intensity, the polarization is directly proportional to the intensity of external electric field. That C, that is electric susceptibility. So electric susceptibility means how fast it receives the electric field inside the material. That is electric susceptibility. So maximum they are linear isotropic. The dielectrics are maximum linear isotropic. Then that susceptibility means, so to consider this a material, so electric field lines passes through the material. So how fast it allows the electric field. So it's somewhat similar to susceptibility, permittivity, permeability, epsilon naught, mu naught, similar to that. How it allows the electric field lines inside the material is electric susceptibility. Then, so now we have discussed three different topics. First one, dielectric or insulators. So dielectric is a non-conducting material, so they do not have free electrons. The free electrons are bound inside the nucleus, bound inside the atoms. Then dielectrics may be a non-polar and polar. So non-polar means positive and negative charges coincide each other. Then if you apply electric field, there is an induced dipole moment. Example, hydrogen, oxygen, carbon dioxide. If it is a polar, so it's a permanent dipole moment. By applying electric field, the dipoles align themselves in the direction of electric field. Example, water, H2O, N2O, NH3 and HCl. And finally polarization. So polarization is by applying electric field, there is a production of induced dipole moments. So polarization is defined as total dipole moment per unit volume. So polarization is directly proportional to the strength of the external electric field. Here that C, we call it as C is electric susceptibility. So depend upon the character, the material is bearing. Okay students.